Maybe I haven't shared. Hang on. I'm going to solve this using that factoring method. And so these steps, again, we looked at these with one problem last week. We're going to do 3 more problems where we look at this factoring method. Now, again, some of you may already know a method for factoring these. If you do, the best thing to do is use the method you already know. So really what we're doing here are for students who don't know how to do this, who don't know how to factor these things. This is at least something that gives you kind of a fighting chance to kind of figure out quickly a way to do this. So, okay, you always start by multiplying the first times the last number. And by that, technically, I mean the coefficient of the x squared term, in this case 2, times the constant term, in this case 10. So over here, I'm just going to write 2 times 10, which we know is 20, but whatever it is, it's 2 times 10. Important to note that it's positive 2 times positive 10, so that is a positive number. That's important because if you multiply these and they're both positive, that means here in a minute when we look for our 2 numbers, they'll need to have the same sign because they're going to need to multiply this positive number, which happens to be positive 20, right? Okay, so all we really want this for is to do its factor tree. We've got 2 times 10, and 10 is 2 times 5. And so we've got 2 times 2 times 5. So I'll just write that down, 2 times 2 times 5. I'm looking for 2 numbers that multiply to be this number, which is positive 20. That simply, all that means is that these 2 numbers have to have the same sign because they multiply to be positive, and they have to use every one of these prime factors somewhere within those 2 numbers. Here's the other thing that has to happen though. Those same 2 numbers, they're going to multiply to be this positive 20 number, have to add to be negative 9. So y'all should see right away that both numbers have to be negatives. Everybody see why that's true? Because they have to multiply to be positive, so they have to have the same sign. But they have to add to be negative. So if they have the same sign and add to be negative, they must both be negative. So what are the 2 numbers? Negative 4 and negative 5. So if you took these 2 together, 2 times 2 is 4. So that gives us negative 4. Remember, whatever you don't take for one number, you have to take all the remaining factors for the other number. In this case, that would be 5 and negative 5. And we see that those are the numbers we're looking for because those 2 numbers, negative 4 plus negative 5, add up to negative 9. Everybody with me? So we found our 2 numbers. Now we're going to factor, and this is where we've got a couple little things we got to remember to do. So we always, once we write these numbers down, it does not matter which number gets written first. We happen to write the negative 4 first. You always now look from the first number in your equation, in other words, the coefficient of that x squared term, you look from there down to the first number that you wrote down. And for us, the first number we wrote down was negative 4. You have to find the greatest common factor of those 2 numbers, 2 and so what is the greatest common factor of 2 and negative 4? Say again? 2. I agree. 2 is the biggest number that's a factor of both 2 and negative 4. So that greatest common factor, 2, that's what we need here at the beginning of the first set of parentheses. We'll write 2x. That is not me. Okay, so does everybody see where I got this 2x from? It's important to see that because this is how you get started. So you look at the greatest, you look at the coefficient of your x squared term, and you look at the first number that you found of those 2 you wrote down. You find their greatest common factor. In this case, it's 2. Whatever that greatest common factor is, you just write that times x at the beginning of the first set of parentheses. Everybody good? Then That number we just wrote down, that 2, now we need to look back down at the first number we found. So from this 2 that we just put up here as our first term, 2x, back down to this first number, -4, we have to figure out what do we multiply 2 times to get -4. -2, I agree. So we need to multiply that 2 times -2 to get -4. Then -2 is what goes at the back end of the second set of parentheses. Everybody see that? Okay. Now that you know these 2 terms, you should be able to figure out the rest of the terms. Does everybody see that if this set of parentheses starts with 2x, the second set of parentheses has to just start with x or 1x? Because those 2 terms have to multiply to be 2x squared. Everybody see that? Well, 2x times x is 2x squared. And if this last number here is -2, what has to be the last number here? -5, right? Because remember, these last numbers have, y'all look, they have to multiply to be +10. Everybody see that? So if this one's -2, this one has to be -5. Everybody with me? Okay, so we got it factored. So the problem we were trying to solve, the equation we were trying to solve, was 2x squared minus 9x plus 10 equals 0. We factored this, so now we have 2x minus 5 times x minus 2 equals 0. So hopefully at this point everybody can see that 2 is the solution that goes with the second factor, right? Remember, we're looking for what would I plug in place of x to make that factor 0? Well, 2 minus 2 is 0. So if x is 2, I get 0 in the second factor. What would I need to replace x with so that I get 0 in this first factor? Well, 2, let's just see what happens if we do that. 2 times, she said 5. 2 times 5 is 10. 10 minus 5 is 5, not 0. So it must not be that. If this was just x minus 5, it would be 5, right? But it's 2x minus 5. So what should I replace it with? Well, 2 times 1 is 2, and 2 minus 5 is -3, not 0. Okay, I'm going to show y'all a trick. I'm going to show you a shortcut where you can just look at it and know the answer. With that said, we'll look at why that shortcut works, but here's the shortcut. If you look at what we did here in this second factor, it's obvious that 2 minus 2 is 0. But do y'all agree that x is 1 times x? So that second factor is 1x minus 2. So what if I did this? What if I said x equals, what if I just, in this second factor, so ignore this first one for a minute, just look here. What if I change the sign of that number? Instead of -2, I reverse its sign and make it +2. And what if I then put it over the coefficient of that x term, which in this second factor is just +1? That would give me +2 over +1, which is +2. And that turns out to be the number that we plug in to make the second factor 0. Now, obviously doing that's overkill because you can just look here. But what if we did that here? If we did that same trick here, if we just reverse the sign of the constant term and put it over the coefficient of the x term, what would we get? +5 over 2. Do y'all agree? If we make that -5, the constant term in that first factor, make the -5 a +5, put it over the coefficient of the x term, which is 2, we would get x equal 5/2. Well, guess what? That's the other solution to the equation. So the two solutions to the equation are x equals 5/2 and x equal 2. Here's why this shortcut works. Let's look at this real quickly. If you look at that first factor, 2x minus 5, you don't really have to just know what makes that 0 off the top of your head. Y'all, look what I'm writing while you listen to what I'm saying. You need to know what value of x makes that factor, 2x minus 5, equal 0. Do y'all agree? Don't we all know how to solve this equation now? This was section 1.2. All you got to do is get x by itself. Look at what happens when you do that. Well, the first thing you're going to do is add 5 to each side. And when you do, you get 2x by itself on the left side. Now notice over here, because you're adding 5 to both sides, but what you've got over here is 0, what you actually get on the right-hand side, y'all look, it's that number, -5, except with the opposite sign, right? You reverse the sign because you added it to get rid of it on the left, but you're adding it to 0. So you just get that -5 except with its sign reverse. And of course, at the end of this process, we got to divide each side by 2 to get x by itself. Do y'all see that? And you can also see with this 2x minus 5 factor, 2x minus 5, you can see why this number works, because if I replace the x that goes here with 5 over 2, do you see why it's going to make that factor 0? Because these 2's cancel. And what does that leave me with? 5 minus 5, which is 0. So the two solutions to that equation are 5/2 and 2. I'll tell y'all what I'm trying to do here real quick. Y'all bear with me.